Hi everybody. In this video I'm going to talk about how to determine the type of solution you would have from solving a basic Algebra 1 equation. There are three types of equations that you should be aware of, or rather three types of solutions to equations that you should be aware of. The first would be that an equation would give you one solution. Now in Algebra 1 it is possible to get more than one solution, especially if you're doing absolute value equations, but we're not going to tackle that type in this video. We're going to talk about equations that, when they have a solution, have one solution. The second possibility is that the end of an equation could have infinite solutions. So that means that no matter what number is chosen for the variable, the number chosen would work. The third possibility is that the result of the equation is that there is no solution to that equation. It cannot be solved. There's no value which would make the equation work at all. So those are the three possibilities: one solution, infinite, and none. We're going to start with the first case, which is one solution. And two criteria for a one solution equation is that only one number in the end would be able to work. Out of all the universe of numbers, only one would actually work on that equation to make both sides identical. The second thing is that the variable does not disappear. So when you solve it and you're done, when it has one solution, you'll still see the variable alongside a number. So let's take a look at this example here, and we'll begin to break this down. So in this one, the first thing that I would do is join the variables on one side. That's the only way that they could be combined. So you could not take, for example, 5x plus 8x and simply make 13x. That would be incorrect. So the right way to do it is join them on one side. So I'm going to subtract 5x from here, move it over there. And what I get is I get 3 is equal to 3x. Now when I divide both sides by 3, what happens is I get my answer, which is 1. And what this means is that out of all the universe of numbers, the value 1 is the only number which would make both sides of this equation the same. And I can do a quick answer check to prove this to you. So if I were to take my answer and replace it where the variable is, which is right over here and right over there, what I would get is 5 times 1 plus 3 would be the same as simply multiplying 8 times 1. So as you can see, I get 5 plus 3, which is 8, and then 8 is equal to 8, which means because it's reflexive, the answer I got and tested, which is the 1, is the right solution. Okay, moving on to the next example, case 2, infinite solutions. So when there are infinite solutions, it means that the number of solutions that can work are limitless. There is no end to them. And this covers both positive, negative, as well as 0, as well as all irrational and rational numbers, meaning decimals, whether they are finite or infinite. So a couple of criteria are, number 1, the variable disappears when there is no solution. And number 2, all numbers work, as I just said. So with that, let's go ahead and jump right into this one. The first thing that I would have to do is go ahead and distribute that 4 inside. So what I get is 4x plus 20. And then I get 4x plus 20. Now one thing to note before I continue is that both sides, if you haven't yet noticed, both sides are identical. And this is important because when you look at both sides and you think, what variable would make both sides identical? Well, it turns out because they are already identical, 4x plus 20 here, 4x plus 20 there, it doesn't matter what value you would choose, anything would make both sides the same. And this is one reason that we can use to explain why there are infinite solutions. But I'm going to take this a little further and actually solve this to its end, and that way you can see something else to consider. So I'm going to solve this as if I'm still looking for the value of x. So I'm going to subtract 4x here and 4x right there. Now my variable disappears, and I'm left with a statement that says 20 is equal to 20. Now, as I said before, the variable disappears, and it just happened that way, right? It just disappeared when I use the subtraction property. What I'm left with is a statement that I now have to think about and consider how valid it is. If you consider 20 being equal to 20, this has to do with the reflexive property of equality. And because it's reflexive, what this means, and this is the other way to think about why there are infinite solutions. Because it's reflexive, what this means is that any value that you substitute in for x would result in a statement that is true no matter what. And I can give this as a simple example to you. If I were to choose, let's say I were to choose 3, okay? Then what I would get is 4 times 3 plus 20 is equal to, and on the other side, 4 times 3 plus 5. The reason I'm doing it like that is because when you want to check a value to see if it's the right solution, you go back to the original equation. So this is 12 plus 20, which is 32. And on the right side, what I would get is 4 times 8, using the order of operations, and that is also 32. Now, you can see that because this is reflexive, the value that I chose, which was a 3, and that I substituted here and there, it resulted in something that is a true statement. Now, this will work anytime you choose any number in the universe. And so for that reason, there's an infinite number of solutions. Let's move on to the next one. The last case is when there is no solution. One thing that that you might have noticed by now is that the first criteria is that the variable disappears. And this very same thing happened when we looked at the previous case with infinite solutions. So this is one thing that that these two cases, numbers 2 and 3, have in common. The variable will disappear if you continue to solve it to the end as if you're looking for the variable. The other criteria is that no numbers would work. So unlike infinite solutions, no solution implies that there is no value in the known universe of numbers that would ever make both sides of any equation, or this particular equation, identical at all. So what we're going to do is we're going to approach this as if we're trying to solve the equation looking for the value of x. So like I did last time, I'm going to subtract 2x here with the idea that I want to join like terms on one side. So what I get is, when I do that, is that these and these both eliminate each other. And just like that, we met the first criteria, which is the variable disappears. And so what we're left with, and this is how this is different from case number 2 with infinite solutions, what we're left with is 7 is equal to 5. And like last time, we have to now consider how valid and true this statement is. 7 is equal to 5. Well, 7 is not equal to 5, as we all know. That's obvious. But because they're not equal to each other, what this means is, like when you substitute a solution and you check to see if it's correct, when you don't get a reflexive statement like we did over here, right? When we got a reflexive statement here, it meant that the value we put in there, it will work, whatever it is. But when we get something that does not make any sense, that is not true, what this means is that nothing will work at all, nothing. And you can choose any type of value, again, positive, negative, 0, any type of decimal, whether it's finite or infinite, nothing will ever make both sides come out to the same thing. They'll never agree with each other. And so for that reason, there is no solution to this. Okay, so I hope this video helped you better understand the three possible outcomes for solving a basic Algebra 1 type equation. If you have any comments or questions, please stop by and leave them for me. I do read them. And as always, thanks for stopping by and taking time to watch. See you next time. Bye-bye.